Okay, so let's transition to the last major part of the course material, and that is talking about web programming in the context of a mobile device. I'll have another motivational talk, if you will, talking about why this is important, what is kind of going on in this space. But from our perspective, the reason this is important is because, you know, basically the phone, the tablet has become the predominant computing device, at least a predominant computing device in terms of content consumption, of web page consumption, web application consumption. Just about any major study would show you that that's the personal computing trend. Um, and from this perspective, you have a few different choices when developing for the mobile platform. One of which is to leverage your existing web investments and effectively program what looks to be a web app, but is really, in fact, or what looks I'm sorry, what looks to be a native app, but is in fact really a web application underneath the hood. Um, I'm going to do that motivational talk next. That was a 30-second overview. What I actually want to talk about first is to give you on the Android platform an idea of the different components that make up an application. And this is an overview one. We're only going to really spend time basically in one of these, the first one called an activity. But I do want to give you an overview of how applications in general on the Android platform are structured as a frame of reference. More detailed exposition on the architecture and so forth of applications on Android, iOS, and other platforms is left to your follow-on course, SER 423. So let's talk about the four main app components, if you will. Um, let me get my PowerPoint going. There's basically four of them when you look at Android, and there's a class type associated with each one of these. But really, this isn't a code level discussion we're going to have, although there might be some sample snippets of code here and there. This is conceptual. Our first type of component is an activity. An activity represents a single screen with some kind of UI. Something's visible that's going on the device. I'll keep holding on up my phone here. I'm bringing up my Facebook here, and when you look at what's going on my Facebook right now, that's an activity going on right now on my screen, if you will. It's what I see. And notice there's only one activity on the screen at a time, so we'll talk about activities quite a bit. The other three, not so much, but I do want to talk about them some today so you get an idea of the architecture. The next one is a service. A service is a component that runs in the background to perform long-running operations or to perform work for remote processes. So a service is used just like kind of a Windows service, or if you're a Mac or Linux person, it's typically called a daemon or a background process that's running all the time on your machine. They may listen for system level events. They may be doing long running pieces of work in the background when there's open CPU cycles. They may wake up in response to some remote process doing something and requesting something from the system. That kind of the same kind of analogy. You can write your own services that kind of extend your application and present it and interface it to the system and to other applications, but even also within your own application if need be. So we'll talk about that. Content providers. A content provider manages a shared set of app data. Basically, it's someone owns some app level data and is willing to share some part of it with other applications under a particular permissions model. So it's kind of a projection of your data that might be a form of data integration you need to do between applications in a structured way that Android facilitates. And then a broadcast receiver, which, I mean, first of all, here says response to system-wide broadcast announcement, and yes, it does. But there may also be other kinds of events, if you will, that you receive a broadcast message. All right, so it's called a broadcast receiver because your component receives broadcast messages. Message, if you will, that's put out onto the system level, system-wide message bus that you may or may not be interested in. And again, there's remote and local versions of this as well that we'll talk about. So let's jump into it. The first one is an activity set from our perspective. From this class's perspective, it's the most important one. It's the most appy one. It again represents what's on your screen, if you will. But it's and actually let me emphasize this back in this slide, all four of these things are app components of a single application. All right, they're not distinct applications, they're not many applications. These, all four of these, you could have many activities, several services, some content providers, multiple broadcast receivers, all rolled into one app. We tend to equate the app with the activity, the thing we see on a screen and interact with, but in fact, an app in Android are all these components rolled into one, if you will. All right. From that perspective, the closest analogy we'll talk about is our servlet framework that we talked about with our web application architectures. But I'll get to that. So let me return back to activities. All right. Again, activity implements a single focused task a user can do. So basically, and there's some examples: dial number, add a content, or whatnot. But looking at the bottom part of the screen, what you typically do is equate this to your design. Think of the design you did, for example, in 315. You had activities in a storyboard-like graph, right? Normally you set out, here's a set of actions that somebody would do, and then they would take some action, go to a new screen. This is like our page turning in our web, right? They take some action, there's some new state of the UI, and you'd lead somebody through the set of things that they would do to achieve some goal, if you will. Activities are kind of like that. Normally you go through this modeling exercise to identify the set of activities, the set of screens that you want somebody to, your end users to interact with. And those are kind of the logical steps of what somebody would do. So in each one of these, this is somebody does something, and it shows on the screen, and those actions or events are handled, and you go to the next screen. Now again, this is a simplification. There are other UI types, if you will, in Android. There's fragments, there's page flippers, or view flippers they're called. The actual literal viewable part of a screen is in fact called a view, if you will, not the activity itself. Activities have views that they bind to, almost like our model view controller architecture. But for our intents and purposes, what we're talking about is we have a set of things we want to enable users to do on the screen in our app with some flow between them, some way of transitioning between them, and that's kind of how we do our app design, and that's how we identify this set of activities. All right. Typically, what this one means down here, I'm on this. It says you will code some activities others provided by the system. What do we mean by that? All right, I'm going to switch over here and go to my and do my scribbling. What we mean by that is, okay, so I decided I'm going to design a set of screens to do some things, right? And these are all activities, is what we're saying. Technically, again, they're views of activities, but the activity is the logical concept behind them. Some event happens here, a button click, a hyperlink press, a swipe, right? Whatever the event is, or it could be a system level event, right? I'm going through and doing this activity. So maybe this activity is Facebook homepage, right? Well, the next event, and then maybe I click on a particular user, right? So now I'm looking at my friend's profile page or something, their page that shows who they are. But maybe the next event, right? So this was a tap on a mobile device. Well, this next event might have been a notification. Maybe somebody sent you a text message. And so up in the top part of your screen, which is called the action bar or status bar, you see a little icon that says somebody sent you a text message. And so that event comes in, and your action would be to swipe down on the parent screen, right? Well, that's actually a different application. That's the launcher application, and you swipe down, you see the set of notifications here. I'm not switching colors very well. Notifications here, and then you tap on one of those, right? Another tap, and now you're jumping into your text messaging application, right? And maybe you start doing some events to send a text back, right? But you're going to stay on that same view, and eventually you're going to terminate that, and you're going to go back, and you want to go back to where you were, when you were looking in Facebook. So you have this this sequence of things that you're doing that brings up other things, right? Maybe inside of Facebook, somebody sends you a map link. They're trying to explain where they are, and so when you're back here, the next thing you do is you go off and you click on a map link. And then Android responds with a new screen that comes from a mapping application. And I'm in different colors here because here's one app, here's another application, here's some system involvement, right down through here, and then here's another application. Yet they're all happening in this same stream, all right? And that's why it says back here that we code some activities explicitly, but others provided by the system. What does that mean? They're provided by the system, or it should say provided by other apps as well. Okay. And the reason why is this sequence can include types of things we want to do, like click on a map link, but not necessarily have to specify what specific app we're jumping between, right? Another would be a web link. Maybe it was a web link on Facebook. You click on it, you could wind up in your external browser. Or maybe the system asks you what app you want to use. Why does it do that? What happens with activities, and I'm kind of getting forward to the next slide. Well, the bottom's the one in this one. Android manages all your current activities on Activity Stack. I'm gonna number these, right? So I'm gonna do 1, 2, 3, 4, 5, 6, 7. All right. In this hypothetical interaction I just talked about, there is a stack that's built. I was doing my first activity 1, bottom of the stack, the current thing on the screen. I went and looked at my friend's profile page in Facebook. That was activity 2. All right. There's my top of stack pointer. Step 3 is I went to the launcher for some notification thing, and then I tapped or swiped on it, right? So I had to swipe the pull down screen you see when you swipe down on something. And again, this whole time my I'll go away on screen keyboard. Didn't mean to hit that. This whole time my pointer is going to the top of the stack, right? That's the current thing that's on the screen. When I swipe down, I see it. That's actually going to be a different kind of screen widget, but same concept. What was the next thing we did back here? After we swiped, oh, we tapped on it, right? We were notified, then we tapped and we brought up the SMS. So the next thing that happens is the SMS shows up. And then, you know, what happened after we did a couple SMS interactions? We went back, right? So how did we get and follow this link right here, right? When you go directly back there, we start hitting back buttons, right? So we start interacting, we start popping the stack. When we hit the Android back button at the bottom of our screen, what we're really doing is saying, okay, I'm done with that activity, go back to the previous one. I'm done with that activity, go back to the previous one. I'm done with that activity, and now I'm back into Facebook. All right, so it's managing this set of screens and these set of single interactions the user is doing on its activity stack via that stack mechanism. It's almost like a call stack you're used to doing in your program, except this obviously involves multiple applications. And sometimes when I go through this and I go back to this state of the stack where I have 1 and 2, and then the next thing I did is now I'm going to go over and do 7, right, the map application. Well, sometimes that happens. I don't even know the mapping application. Maybe I have multiple mapping applications defined on my computer, and I have to resolve what activity is actually going to take over and handle the map request that I make. That's the purpose of our next thing called an intent. I'm going to switch to intents, and then I'm going to come back to the activity state diagram. Intents are not one of the 4 app components. If you notice on my welcome slides, right? It's not one of the 4 that I put up there. But yet I put it here talking with activities. And that's because normally we think of intents associated with activities, but that's not necessarily the case. Intents can be used to start an activity, they can be used to start a service, they can be used to deliver a broadcast to a receiver, meaning they can involve activities, services, broadcast receivers, 3 of the 4 components we talked about. Technically what it is a messaging object used to send a request and action from another app component. The word intent's used because it implies future action. Right? There's a future response that's sent here, meaning and the most common thing is to specify a future activity that you want to have happen. Meaning you basically want to say, in the future, I expect there's going to be some event or something that happens, and when that happens, I want you to go do this activity. All right. Now the length of time in here is variable. It could be immediate. It could be after some period of time. It depends on what the event is that's going to bind those two things together. So for example, it could be initiated by the system, meaning the arrival of the text message causing the notification to be fired, or perhaps if it's an urgent message, like an Amber Alert or something, it shows up and takes over your screen immediately. All right. So it doesn't always have to be a user initiated action. There are two types of intents to worry about. One's called an explicit, one's called an implicit. In an explicit one, and it's explained here, you know, as the programmer, the target activity in class. You know the app. Right? Not only that, but it could be your own. You can define an intent to bring up let's say an activity defined within your own application itself, meaning it's one of your own app components, and that's actually very common. If it's inside your own app, then usually you know, right? Well, usually you do know about it. You know what context under which it should be set and what the target activity class is. You know what activity it is you're defining. Activities are represented as the class type, as we mentioned back here at the beginning. So you know the Android app.activity type that you already or that already exists within your app. So you can programmatically set it up. You can explicitly call start activity on it. You can make starting the activity conditional based on some result and so forth. But that's called an explicit intent because you know what you want to have happen, specifically down to the code level, what the target activity class is. But I wanted to include that mapping example and the fact that you could have multiple map applications on your device, and maybe you need to choose between them. A common one is video playing or photos, right? I mean, I always seem to have multiple media applications on my phone, and somebody sends me a video, and I tap on it after that delivery, and the phone asks me, "Hey, which one of your media applications do you want to actually view the video?" Right? Well, why does it do that? Because what actually happened there is we got an event for the video, and we told Android that we want to start the activity, but that's represented by that intent. That intent in this case, by the way, would be play a video, or in the first case, we show a map of something. Maybe you sent me coordinates. All right. The point is that intent actually goes to the Android system. The Android system says, okay, what video players do I have registered with the system, or what mapping applications do I have? And when it does that, it basically says, okay, did they already specify a default? Meaning when I get requested by the system for this type of action, do I already know what the user's preference is and I can use that, or do I have to ask the user? And if there's no preference that it knows about, that's when you get the pop-up dialog saying, what do you want to do? If I've already specified a default one, then I don't get asked that one. That default's used. Okay, and then the system will basically redefine that to a specific intent, saying, oh, they want to bring up Google Maps, so they want to bring up OpenStreetMap application, or if it's the map, if it's a video, hey, we want to bring up VLC, we want to bring up what's the default video player in my gallery app. All right, so that it adds this level of indirection in the binding, where the system sits between what one app wants with some activity and the activities provided by another application. All right, these two are different applications on either side of here is the point. If it was the same application, meaning if activity A and activity B were defined within the same application, why wouldn't I just use an explicit intent? I would already know the target activity class that's in my same application. It's part of my family of components in that application. So this guy could just directly call, lost my thing there, this guy could call start activity. All right, so this level of indirection means the system provides kind of a brokering relationship between things. How does it do that? Well, we'll talk about the details, but the upshot is basically every application presents a manifest to Android. All right, by analogy. So let me go and have this discussion now. I'm going to kind of go into how this model works in a little more detail and put aside the components and intents right now. If you remember, we talked about one component container model already this semester, and we talked about a container which was a servlet container, and I showed you examples of a reference implementation called Tomcat, for example, which had the Catalina engine in it, right? But in there we had a set of applications running inside of this container, and each individual application was comprised of a set of components called servlets. And the configuration of these things was done via a file called a web.xml. And in the web.xml, which was under a particular directory structure, that was the packaging part, right? We have a packaging part in the servlet specification. It said under the webinf directory, you're going to have a developer provided web.xml, and it's going to list out what all of the servlets are, you know, servlet 1, servlet 2, servlet 3, and it would also explain its routing logic, which means it gave you it gave it a name, but then it gave it a mapping, and that mapping was to some relative URL, so that when an outside browser application hit this container through Tomcat and routed it to the right app, which would then route it to here, and then it would look up its locally its part of the relative path and say, okay, that corresponds to this particular servlet, and I'm going to invoke the do get or do post or do put or do patch based on what HTTP verb was sent in. So why am I going back and talking about web development in the context of an Android lecture? Because this is a very similar thing is going on, a very analogous thing. Here we have our container is the Android system. And all those little apps that you see on your screen, all right, have these 4 components: the activities, the broadcast receivers, the content provider, and the services, all defined within a particular app. And these are all defined in a file called Android, I'm going to run out of space, Android manifest.xml. And in that Android manifest, we specify all those things that we have in our system. That's also the place, connecting this all the way back to our notion of intents, it also will expose what types of intents it can handle, including things like if the system gets a request to show a map, hey, I've got an activity that you could bring up that can handle that map. All right, that's the point of it. That indirection happens by you registering an application through your manifest, right? Why the term manifest? Well, what's a manifest mean? An airplane manifest, a ship's manifest. It documents the contents of something, all right, and expresses what's in there and what type of stuff, what's in your cargo. That's what the manifest does. It explains the cargo in terms of the components it has and a few other things, but primarily the components it has for your application. All right, the application itself is packaged into these files called APKs, and there's been some binary changes in Android recently, but for all intents and purposes, we have our own kind of compressed archive file called an APK that's presented to Android. Android knows how to inspect that, and it's looking for this. It's looking for this, and it's looking at a particular directory structure too, which is exactly what we saw happen when we handed a war file, .war, to a servlet container. That was just a zip file with a particular directory structure and a particular manifest embedded within a particular place in it, so it knew how to find it. All right, and there were different rules for where different things go inside of that application. You know, we didn't spend a ton of time on servlets. I know that the servlet structure is not second nature to you. I'm using servlets as the analogy for component container computing, because that's effectively what we're doing again in Android. The rules aren't exactly the same as servlets. The rules aren't the same as you go from component container to component container type of programming, but the architectural style is. All right. The apps are provided some kinds of services by the container to do stuff. In Tomcat land and Servlet land with Catalina, those things include lifecycle management through a management tool. They include a JMX interface to help build external tools to inspect and react to that lifecycle. Provides deployment services and all these and URL routing services to listen to the ports and connectors. That's what's in your server XML. Here in Android, you're provided services to put applications on your phone, to have them understood by the framework and managed by Android under different situations in your phone. Phone call comes in, batteries draining. Think of anything that goes on at a system level. All right. Android is, you're writing applications and you're writing these components and packaging to them. You don't write a main program anymore, right? You're writing these different components that plug into this framework in a well-defined way, which means your applications have to know how to play in this space. And the difference between mobile platforms are basically the rules and the specifics about how they play in that space and how lifecycle management's done and other events are done, and the specifics of the services provided by those frameworks. Because even though they're similar, they're not exactly the same. Android, iOS, Windows Mobile, what have you. All right. So that was a long aside going back to this notion, but that's why we have this level of indirection with the maps. We're basically saying in one app that, hey, I need a map, but how would that app know what maps you have? And what happens if you had a map app over here, but then you uninstalled it and got a new one down here, right? You're not going to tightly couple to these things. No, what happens is I need a map. That request goes to Android, and Android knows about the apps that have registered to it to know to bring up what map is there, what map is your preference, or whether to ask you, because you have more than one map application, you have an M1 and an M2, and maybe there's no default preference known, so you got to go ask Android how to bring those up, which one to bring up. Okay, all that going on with the concept of intents. All right, now I'm going to go back to activities, because that's our main thing. I talked about intents and went forward in that because I wanted you to understand the overall structure of an application and the component-based framework and the containers and all that. But the main thing to know about intents specifically is the most common use case for them is to specify a future action. Meaning in your application, when you render the button that says I want to go to a map, you would code that by creating an intent object and giving it to that event handler, saying, okay, when this button's pressed, I want this future thing to happen. That future thing is an intent, and I'm going to wrap in a context for it and what activity I want to have brought up, or at least what activity I'm going to request of the system to bring up the mapping application. That's what an intent does. That's why it's implied to have this promise of future action, if you will. But it's not an app component itself. It's really just an object type in Android. Our app component is itself an activity. And going back to the component container lifecycle and going back to our activity stack, really, going back here to our activity stack, when we're managing when we do component-based computing, we're very interested in lifecycle events. We're interested in knowing what the different states are that some component can be in. And from an activity perspective, this is the state model. This is your state chart that you know from UML for activities. So what happens is an activity is launched, meaning you're on the launching application, a special application in Android, and you go tap on it, right? So I'm on this default screen that you see on here. I'll hold it up. This is a launcher, right? It's all the other applications are rendered on it. All the things that that had Android manifests that presented themselves to Android. And I might bring up my Slack, let's say, So how do I do that? I tap on it, right? And it comes up. Well, how'd that happen? What just happened there is the activity was launched via a tap, all right? And Slack was created, all right? Meaning it was the activity had to be instantiated, and then it had to be started. And then it goes through something called on resume, which seems kind of weird. You're starting it for the first time, but you have to resume it. But that's only so they have a logical ordering to the call chain that goes on here before the activity is actually running. All that happens, this is when it's on the screen, right? And responding to, I'm going to type in stuff or whatnot. I'm interacting. I'm doing the user interaction in my Slack app for representing the screen. Okay. Now what happens if something else goes on? So I'm in my Slack, and I got some Gmail up there. This is probably a very strange way to demo this. I probably should have the doc cam out. So I don't know if you can see that, but you can get the idea. I swipe down to my notification, and there's a couple notifications there, and I got an email from my school district. All right, I bring up. So where am I now? I'm in Gmail, right? Well, what happened to my activity running of my Slack app? Well, some other activity came into the foreground, right? Gmail came into the foreground. So my Slack application got a pause event that it can react to using on pause. All right. So the app is paused. At this point, I can immediately go back to the activity, or the activity, perhaps when I was paused, some other thing actually took over the screen, so it's no longer visible. Then I get a stop. All right, so I'm giving you these are very fine-grained. Even in one user action, there's a distinction between pausing and stopping. Right? And so if I want to restart, I actually go through a different path with other event handlers that are going to be implemented. Restart, and then back to my onStart. Why are these separated? Well, maybe on restart I need to restore some state. So what's going to happen is I'm off the screen now, and you see that Android back button on the bottom. I'm going to back button it. Right? Now, one thing is, notice how I went back to the list of my email. I'm going to explain that in a second. And then I hit the back button again, and I'm back to the home screen, right? If I want to bring back up Slack, right, I had to tap on it again. So what happened there is the activity stack actually got reprogrammed by an application. Applications have the ability to programmatically manipulate what goes on the activity stack. So it's not just a straight mapping of the user actions. You can actually insert additional activities or reorder activities in the background on the activity stack when your actual application is brought up. That's kind of notorious for, like, Facebook is very notorious for this. You bring it up the first time and it takes 3 back button hits to get out of it and back to the launcher. Why is that? Because they want to keep you in the app. Right? A lot of apps are like that. Gmail did the same thing. I didn't go to the main navigation screen. I went right to an email, but it put 2 things on the activity stack. Right? It put the email on the top, but then it also had the email nav or listing that it programmatically put on there, even though I didn't get that the first time I entered it. Moral of the story, apps can actually control what kind of things go on the activity stack. Back to the state model, though, from the perspective of our Slack, is we came back on screen, so we get a restart that we can call and a start. And again, these are different because maybe I had to reset the state of something. Maybe I had started to type something in, some kind of message in on Slack, and I needed to use restart to maintain what thing I had partially typed in. It just doesn't stay there automatically. I've actually got to save that, and then when the app is restored, re-render that partial message I was typing in on the screen, because going down the default path just through onStart, like it was the first time I executed it, it wouldn't have thought anything was there. All right, so this is one way we can do stateful programming, and I know you know what that is by now. All right. Now, some things can happen at any point in time. So I'm doing a stop. Well, let me finish the chain. I'm going to go back to the special case. So I'm in it on stop, but maybe the activity finished. Maybe I did something in the app, and now I'm just done using the app. And the app knows it, whatever the last thing was. Maybe I was buying a plane ticket, and when I'm done, I just want to close the app. You can programmatically close an app. All right, so this is the close the app. Right? Or usually you have an explicit manipulator either through the system menu or through this multi-app icon down the bottom, where I can bring up all the apps that are currently available, and I can go to Facebook, let's say they're in the middle, swipe it out of the way, and it's gone, right? What I just did is I just said I'm going to destroy that instance of that application, or at least that application component, that activity. All right. So I basically have a destructor, something that is called just before all that happened, just in case maybe there was something there on Facebook I needed to write to its local data store, however it's storing data. And there's multiple ways to store data, so I'll just say that generically. Maybe there was something it wanted to save for the next time you totally restart the app in the app instance. But from our particular activities perspective, when I swiped it out of the way, I killed it, and I had one last event handler I could do in case there was anything I needed to have happen with respect to that, with persistence being the most common case. Okay, let me return back to here though. I'm in nonstop. I'm still resident in memory. I'm not destroyed. I still have an instance of an activity, but I'm no longer visible. I'm no longer the thing on the top of the activity stack. There isn't anything to it. Now, what happens is if I have a lot, I mean, look, this is still my chooser up. I got a bunch of applications up on this thing. If you have, less memory on your phone, a lower power phone, or if the battery is starting to drain on your phone, the phone will actually switch to a lower power usage modality automatically, typically. And what happens is it starts to conserve resources, which means it's not going to keep as many applications in memory, right? Applications just don't stay in memory forever. You leave your phone out overnight, or maybe you were using Facebook and you haven't touched Facebook in 3 days. Is it going to still be sitting in memory for you to just resume or restart? Well, it could theoretically, but usually what happens is Android's going to kill the process. All right, it also could crash, but typically Android's going to kill the process to conserve resources. Right? Because maybe you are using, resources like memory or CPU or something that's needed by the system. So Android kills you, and if that's the case, then for you to get restarted, you've got to go all the way back to the beginning to the create, because now you no longer have an instance. The app process is killed and it's got to be recreated. Right? So it's quite the involved state model, but it actually, if you study how interactions go in your phone, you can actually really pick out how any application that you download is structured in terms of its state model. In other words, I can use an application and I pretty much know which one of these methods it's doing its stuff in, which one of these event handlers it's doing its stuff in, and when it got one of these events, based on what I see on the screen, what happens when I bring the app back up, and what happens with the activity stack, because I can also determine what the activity stack is typically at any given point in time as I go through back button behavior. All right. This is all very important to us because we're going to see inside our hybrid applications, our web applications, that we already have analogies to this, and we've got to figure out how they play side by side. What do I mean by that? What I mean is when you use a web page, all right, you're in your web browser. Well, let me bring up, why am I drawing it? Let me bring up Firefox. All right, let's go to a web page. Let's see what's going on in the world. Let's go to CNN. All right, I'm sure it's something about Trump. All right, that's the Trump story of the day. Let's do something else. Boy, if I can find anything other than Trump, the whole thing's Trump. Is there any decent fun news going on here? All right, let's talk about even that's it. Let's talk Nicole Kidman trolling Jimmy Fallon. Like, that's interesting, right? But I just went to another page, and even from here, I can change and go back to the address bar and go to another page like ESPN.com, right? Normal web browser stuff. The reason why I mention this is the browser on this tab is doing its own stack, right? Because that's why I have a back button. I can't get that off the screen. Right? I have a back button here. Oh, I'm going to hang my whole browser by hitting some flash. How appropriate in a web development class. But I started in CNN. I went to another CNN page. Now I'm in ESPN. But I have a back button enabled here, right? I go to the back button. I go back to that same page I was in before. What does that mean? It means the browser's keeping my browsing history as a stack-like structure, right? It's entirely analogous to the back button in Android. But the reason why this is important to us is when we go into Android and we start laying out an activity stack where we're doing an activity and another activity. One of these activities in a hybrid app, these activities are going to be native. These are ends. Native activities, meaning written in Java using the activity object type. We are going to write hybrid applications by creating a web activity. All right, and so that activity is essentially going to be running inside of what's called a Chromeless browser, not Google Chrome, but Chromeless, meaning a browser without all the menu and adornments, just the main viewing pane, the rendering pane that we talked about from Garsai's paper. All right, so this is essentially like an embedded browser that we're going to have in here. When we're tooling around on web pages, and as we go from, we switch modalities here, and now we go navigating from page to page, whether it's, and I mean page in a general sense. I don't care if it's Ajax driven or full page turn or whatever. And I go around these things. From Android's perspective, it's still all part of the outer activity. All right. That's basically what happens. Is from Android's perspective, this is all one activity. And if I go to something else, another native activity, this was all one thing. What that means is I start using the back button. I don't start unwinding my browser stack like I intuitively think I will. Instead, I'll just go from unwinding this to unwinding the entire web activity to going back through my activity stack in that direction. That's something I'm going to talk about more as we get to the specifics of web programming, because one of the challenges in doing a hybrid application is kind of providing a consistent user interaction model across native and hybrid, or web activity views as it's called, or web views. All right, so that's foreshadowing. We'll get back to that. All right, I'm going to turn off the Trump news for now and get back to talking about our app components. Okay, so that's why activities are important. The thing we see on the screen, they have a rich state model. Our web activity type, or web view as it's called, meaning the view for our special web activity, is going to be particularly important for writing hybrid applications for us. And the concept of what is on the activity stack for Android at any given point in time is very important. All right. Talked about the intents. Let me talk about the other, and that's mostly what we're going to talk about in our context in this class. You're going to talk about all these types in 423. Let me talk about the other three types pretty quickly here. I want you to be aware of them, but realize we won't be using them for the remainder of this particular course. An Android service intended for long-running tasks, no visible user interface. So an example might be something that you want to do typically in the background, like a file upload. So say back in your Facebook app, you want to upload a file. Well, what normally happens? You click on photo, you bring up a photo picker. It typically has given access to the gallery of your photos, which means you had to do a permission for that. That'll be something called a content provider we'll talk about later. And then the upload starts. When the upload starts, it doesn't actually do it in the activity. It does it in app, but not in the activity. It does that via what's called a local service, meaning it's going to make a start service call, go invoke that file upload service in the background, and when it's done, there's no return for it to do. It's asynchronous. It happens on its own, independent of the activity. So there's no return statement, and it's not asynchronous since we have a callback. It just terminates, right? Which is why if you do upload something to your Facebook, what you normally get is a notification in your status bar to say that that task was done. So you can take a user action to go see, what the result of that task was. All right. So again, two types of services: local one, an activity or component that calls start service. That's the Facebook upload example I just talked about. Notice that it can outlive the application component that started it, which means even if you killed your Facebook activity, maybe you went and started texting, maybe if you went and started reading the news, do whatever, something else on your device, the Facebook upload is still going to go on until it completes. All right, so it can outlive the application component, usually the activity that created it. Right? It can stop itself if it fails. It could be stopped by another application component, which means you can go in and stop an upload if you want, or the system could kill it in the case of it's consuming too many resources, or perhaps if the system detects that it's not functioning properly. Must have went on start command. We're not going to worry about implementation details. All right, so the second kind of service is a remote service. Dependent on the application component bound to it, you could have many bound to it at a time. If the service is not bound to an app component, then it's destroyed and has to implement on-bind. What happens with this kind of service? It's just like an operating system service, a Windows service, a Unix daemon. Well, just like it's very similar to. What happens is this service is created because there are multiple apps, not your own app, but other apps out in the system. So maybe you wrote your own file upload service, right? You got your better file upload algorithm with its compression, and other apps may be using that service at any given point in time. How does it find out about that service? This service, as you guessed, was declared in the Android manifest.xml. So the container, being Android, knows about it and knows that that service exists and is a remote service and can be available under a particular permissions model for use by other applications. Okay, so these applications will express a file upload what? A file upload intent, meaning I want to upload some file. And it'll say what service, what other applications out there can help me. It'll ask Android. Android will say, oh, there was a service defined here to do an upload, so we will bind these guys to that particular thing. Okay. So at first it might seem a little screwy, but this is the way decoupling happens. This is the way I can have multiple file upload services, multiple video processing services, multiple mapping services, multiple whatever services for long running tests. Just like I had activities with that level of indirection, I can do the same thing with services. I just use services for different types of computation, not things that are meant for a UI, but things that are long running tasks meant to be done kind of off screen, but to be done continuously as there are resources available to do it. All right. You can, as a service developer, you can write something so that it can be used both by a local and a remote service, although that's considered a bad practice. Skipping a slide ahead, so these are the life cycle of, just like we had an activity life cycle, a service has a life cycle. These life cycles are much simpler. There's not as many backward links. There's not as many of the ramping up on create, on start, removes kind of thing. And again, that's because we don't have a concept of something being on the screen, the visible part, so we could take those states out of the state model and be with something similar, simpler, I should say, for the service life cycle. But notice that the life cycle here, similar in structure, has some differences, right? That's the same, but this is a bit different, all right? How the services are stopped and unbound is a little bit different, even though they both have a destroy. Why is that? Because back here, whoops, I'm in the wrong thing. I need to be over in my scribbles. Back here we're talking about multiple applications maybe using your service. So when a given application is done, it doesn't by itself know whether or not to tell your service to destroy itself, because it doesn't know if other things are bound to it. Only Android knows that, and therefore if nothing's bound, Android can tell it that service is shut down. You could also indicate to Android that you want the service to stick around even when nothing's bound to it. It's called stickiness. But that kind of, the use of stickiness is a hint to the operating system, not a requirement, because Android is responsible for all resources on the system. So you have to code it in a very safe way, not assuming that your service is always alive. It has to be able to be restarted, if you will. So all these concepts are similar no matter what component container environment you go around to. All right, and these were adopted in mobile platforms as component container because of the limited resource environment and a need for the operating system to have far more control over these different kinds of scenarios. Yeah, your laptop, your desktop computer, like your laptop could run on a battery. It could get a battery low event. There were things like that, services like that built into some of your operating systems for a laptop per se. But when you consider the use cases for a mobile device that you're carrying around, they're a much richer set, right? The resource drains that could happen, the change between cell phone towers, your changes in data bandwidth, your data charges, being in light, the fact that it's a phone, so when you hold it up to the ear, a proximity sensor knows that you're going to talk on the phone because you got an incoming phone call, and does certain things in the system to tell other apps to get out of the way so you can talk on the phone. All this doesn't happen automatically. There needs to be a framework or a structure and a set of ground rules for agreement among how components are going to behave that the system has to have more control over. And that's why there is such tight control, and that's why there is such a difference between native applications. I mean, again, I'm going on a tangent here, and this isn't, we're not really going to do native application development, but you'll see this in 423. Yeah, when you go between Windows and iOS and Android, there are different primary languages, Swift or Objective-C versus Java on the Android versus something off the .NET platform for Windows. But you can actually program in a lot of different languages for these things. Folks have written all kinds of projects to write applications in other languages. The principal difference I'm saying isn't the language that you use as you go from device operating system to device operating system. It's its structural model for things like its set of states and its set of services and how your component has to play in that world. All right, they have different packaging models, they have different deployment descriptors or manifests, they have different set of services, similar concepts but maybe different way of implementing some things. That certainly happens with notifications, for example. So it's all component container based, but it's not the same container, so you can't write your components the same way. That's why you get into a real issue sometimes moving between different native code bases. There's plenty of frameworks out there we talk about that can cross compile to native code on different platforms. The real issue that they have isn't the cross compilation. Cross compilation is not a hard thing to do. The real issue is it's got to cross compile to a different target component container environment and understand the best fit for what the application is trying to do versus the rules of that component container environment. Okay, full of asides today. And we're not even talking about our hybrid apps again. All right, so that's a service lifecycle. I talk about using it for long learning processes. Realize that that doesn't mean it's a new process or a new thread. Don't try and think of it as multi-threaded behavior type of thing. Think of it as another activity but without a visible UI that just runs to its natural termination. Services are not necessarily local. Like I said, I just talked about binding to your service from other applications with the help of Android, and that's why we have that Android manifest again. On the whole nother section of the Android manifest is declaring the set of services that you have, permissions, whether or not that service can be local or not. We talked about the notion of stickiness. All right, a service by default is sticky, particularly if it's a remote service. Android will try and keep it running. And your services will, if you have an application that's comprised of multiple activities and multiple services and content providers and broadcast receivers, Android will try and keep the services alive as long as it possibly can and try and restart them because it views that as something that now becomes almost an extension or decorates the behavior of a system when you have one of these remote services. Remote services are, because they are not specific to a particular class type, are actually defined through this interface language called AIDL, but we won't go over that. Just be aware of that. A system is distinct from the activity that created. Again, this whole notion of an activity like a file upload could spawn the file upload activity but then go away. That activity lifecycle may end. It may do its on destroy, but the service is still running the file upload. All right. Distinction between life cycles, local and remote, like we talked about. So that's that is the deal. Services are really not any different than what you see on an operating system, particularly remote services. It gets a little bit more confusing about this notion of a local service, meaning you can have this long-running activity just for use by your application. And it's not even the best use case. Android has over time introduced more multi-threading, notions of workers, notions of something called an asynchronous task that give you a variety of options of manipulating its event queue. And yes, another foreshadowing, Android has an event queue just like Node.js does. And so now the need for a local service in an application, it exists, but it's not as necessary as it used to be. You have far more programming options to go do tasks in the background depending on how resource intensive they are, how you have to communicate results, how long they last, and so forth. Those are the criteria for those kinds of things. Again, something that is, for our just one module in this class is a bit out of scope, but you'll talk about more in 423. Okay, two other components real quick, because we definitely won't touch on these. One's a broadcast receiver. Simple in concept. You have a set of broadcast messages that are typically delivered by the system. Those messages are typically represented as an intent, meaning somebody wants some activity done. It has its own declaration in the Android manifest of what it's going to, what it's listening out for. You can do it locally, just like services. You can receive your own app messages, but that's kind of awkward, and they're better models typically for doing that, because broadcast receivers like a system level message that comes, that you are interested, something else happened on device, a phone call came in, the battery has gone below 20%, you're running out of memory. Basically, those messages are pushed by the system onto each application so it can take its own constructive actions to remedy the situation in the app as compared to the context provided by the system. That's effectively in concept what a broadcast receiver is meant for. Folks can use them for all kind of interesting things, though, including using them within your own app. But again, a lot of times there's a better way of doing that nowadays through some of these other mechanisms as mentioning. Very interestingly, I don't have a lifecycle model for a broadcast receiver because a broadcast receiver is intended to be transient. This is a transient object. What does that mean? It comes into existence for one purpose: to receive a particular type of message, execute some behavior, some event handler in on receive, and die. It goes away immediately. It's not meant to return. It's not meant to transfer control. It's meant to bind system event, something you want to do that thing, go away kind of thing. All right. Let's see. Well, in effect, I've already talked about this, and this isn't quite important. That's all you really need to know about broad receivers. You're listening for another app or the system to tell you something, and when that thing happens and it's meant for you and you have permissions for it, you go do something, you finish it, and it's done. The broadcast receiver goes away. The fourth and final component is a content provider. What a content provider basically is kind of a data wrapper interface. It's almost like a relational database interface to structured data. It doesn't actually specify a relational database is used, so it's actually up to your app implementation how it supports the interface, but it defines the interface, and that interface provides this very SQL-like. Do I have an example? No. Well, it provides this very SQL-like in terms of these common create, read, update, delete, CRUD API, as it's talked about, and it kind of assumes you have a table's worth of data that you're willing to expose to other applications. Those other applications resolve to certain content providers. And again, this whole concept of provider and resolver gives some level of abstraction so that these, this is your app, this is app 2, app 2, app 2, but maybe you're doing app 1. These two don't explicitly have to know about each other. The content resolver may just be looking for, hey, is there a repository of map type data on this phone? Maybe you have an offline map history that your custom map app has, and you want to provide the ability for other apps to see it. So another app can come on the system and say, oh, there's this offline map application that conforms to this interface and provides me these kinds of CRUD operations for me to create new mapping data, to read the existing mapping data, whatever the permissions allow me to do. Right, that's basically what a content provider does. The rest of this information isn't tremendously important. I mean, you do have other options, is all this saying. You have preferences. You have a file API. You can use an embedded SQLite database. There's a new thing called the Storage Access Framework that provides document level access. So when you're looking to share data, you can kind of go through some more almost desktop-like traditional mechanisms, like I'm just going to write the data out to a file and I'm going to go get permissions in a way for another application to go find that file and read it. Realize for mobile applications device that very often the information that you want to send back and forth is very small, fine-grained transactional information, which is why this interface exists. The kinds of things that you're querying for, the kinds of things that you would insert or update or delete are expected to be very small. All right, they don't have to be, but they're expected that these are going to be fine-grained information appropriate to, the mobile experience. A single text message, a single contact information, right? The contacts is an example of a built-in content provider, and you need to look up something in your contacts. So you want to go query the content provider for contacts. That's a lot easier than your application having to go off and read the file associated or the SQLite database, and it's better as well because then you'd have to know something about the implementation, right? If you're going to exchange data via one of these mechanisms, right, then you got to know this thing's schema. You got to know this thing's file structure. And anytime somebody wants to change that, optimize it, or whatever, it's all clients have to change. Here we've got another level of indirection through this resolver and a standardized way of querying and modifying data. So it means I can resolve to providers of a certain type, like contacts, like maps, and I don't have to know the schema. I don't have to know the file structure. I don't know anything about the physical implementation of the data I'm accessing. I have to just know the abstract interface and be able to go off and execute these kind of query operations on it to retrieve and manipulate fine-grained data. All right, so that's a common way of doing that. All right, summary. This was, whirlwind tour, and I went off, I know, on a couple of aside on intents, component container, and all that. But to give you an idea of, how applications work in Android and mobile systems in general in this component container model, it's a lot like server-based programming. You're not going to write a main program. You're going to write a main activity, but you're not going to write a main program. And in fact, your jumping off activity is really defined by what's in your Android manifest, not by what you name it. You can provide more than one entry point in that manifest file, and some for each of the 4 component types. So all these 4 component types have their own types of entries with their own metadata, again, related to how you access it, what permissions you have, anything particular about it defined for its own metadata that is custom to that particular component type. But in your manifest, if you have an application that uses all 4 component types, and you'll see entries of all 4 component types in the Android manifest. Right? Again, all of these together are the app. We tend to think of just the activity, the visible user interactive portion of the app, as the entire app. The app is all, from a technical perspective, a software structure perspective, it's all of these things together. Right? When you go into your settings and you do your app inspector and look at it, that's why it'll tell you, how many running processes and how many running services it has, because they are independent components, but they are part of one app. They are delivered as one code base. They are described via one Android manifest.xml. They are compiled and built and deployed as one package. All right. The style of programming you're going to use, and since you don't have a main program, is going to be event-driven. User events, tapping and swiping on activities. System events, incoming phone call, message, notification, battery low, whatever. All right, or other apps sending events that translate and get routed to you because you've decided you want to listen to them or you need to pay attention in some regard. All right, so everything you're going to do in a component container model is going to be event-driven. Something is incident on your component. You have to decide what to do. The visual one aside is the visible part, and this is kind of transitioning to tying into what we're going to do, and I'll leave the more abstract stuff to be picked up in 423. The visible part of an activity is its view. All right, so the thing you actually see on the screen is an object called a view. A view is bound to an activity. We're going to focus on a specific type of view called the web view. All right, the web view is essentially an embedded browser, a Chromeless browser, but given that from Android's perspective, where did I put that one? From Android's perspective, this web view wrapping an activity is all one big activity. From a user experience perspective, now we've got to worry about how our back button behaves, how the activity is treated with its life cycle, so that it really acts and behaves more like a native application in order to give that consistent user experience. And we'll have to spend a fair amount of brain power and our development time doing that while trying to maintain some sanity around the code. All right, so we need ways to have it play nicely with native activities. The ability to have these native activities doing some things from your application and a web-based activity doing other things, that's what makes it, that's why we call it hybrid. Okay, we'll talk, we'll switch gears and talk about Android Studio and the code level, but I'll also continue to talk a bit abstractly, if you will, about the nature of hybrid applications, the pros and cons of them versus doing things entirely native. But now you can, now you know kind of the structure of it and what some of the issues are. You can kind of get almost guess already what kind of things go on and what alternatives you're going to have as you move between native, web only, and hybrid applications. All right, so it's a bit of a long intro, over an hour, and I know I did a bunch of asides in there, but the main thing I want you to know out of here again are I'd be able to identify the 4 types of components, be able to understand what an intent is, and understand why lifecycle models for these things exist, and understand a bit about the component container relationship that these app components have and the app as a whole has with Android.